So I have a soft spot for speaking at this particular conference. So many good things have happened. So Eric, I think we met at EUC, and then the second conference we did together was here. There was another one that was pretty special. So Eric was my first Elixir hire at I Can Make It Better. There was another moment that was pretty special. I went to a conference in London, another one that Francesco put on. And so I had brought this ready manuscript for Jose to sign, and I'd kind of stalked him across the pond. I was working at I Can Make It Better, and I didn't quite know what language was next, but I knew it wasn't going to be the one that I was working on. And so I talked to Jose, and I said, could you sign my book, right? And I put it in front of him, and he just kind of rolls his eyes, walks out, and I said, man, I've really embarrassed myself, right? And he comes back with a book, 7 Languages in 7 Weeks, right? Which is one of my books. He says, I know who you are, Bruce, right? And so, I signed the book, and he signed the manuscript. And so then I came back to Austin and tried to convince my boss that we needed to build an application in Elixir, right? And so he said, so what database are you going to use? And I said, well, we don't have a driver yet. And problem solved with Eric, right? And he said, what web server are you going to use? Well, there is one, but I think that Jose is about to discontinue it, so we'll have to figure that out. Don't worry, I got it. And he just turned around and walked out of the room, right? So Jose and I came up with a plan to use to build, rather than to build a web framework. He said, I can't build a language and a web framework. But what we could do was build and by we, I mean Jose, right? Because that's how these things always work. But we could build a Lego kit for building web servers. And so we were going fishing, and we caught Chris McCord. And in the Marine Memorial Hotel, in one of the breakout rooms, Jose and Chris met the first time after we implemented that strategy, and they talked about Phoenix, and the rest is history. So you get you get one more story for your money for this conference. So, oh gosh, I'm on tape, so that's not good. No, it's all great. So this book is one that's near and dear to my heart, maybe more than all the other ones, except maybe 7 Languages in 7 Weeks. Just because the man that I got to write with, his name is James Gray, and he's the best programmer I have ever known, hands down. Really good man, probably a better man than he is a coder, but he knows so much, and that's why he can't write a book by himself, right? Because when he tries to get any sentence out, it comes out with 4 or 5 parentheticals, and he just had to have somebody rein him in, right? So we started writing this together, I guess, a couple of months after he started writing it, and this fills a niche. So Brooke and I were talking at lunch about the idea that there's a lot of advanced material out there. There's a lot of beginners material out there. But there isn't much in the middle, and there isn't much material that kind of talks about the glue or what I should do once I know how a pipe works, I know how width works, I know that I should use widths instead of pipes or pipes instead of widths. I know enumerable, but I don't know what the layers of my application should be. And so that's the hole that we were trying to fill with this one. By the way, if you want to reach me, I'm at Red Rapids. I'm at a company called Groxio Learning. I'm here because so that to convince maybe you to subscribe to our services to kind of learn to code better. But why you're really here is for the bring on the freebies, right? So this is a code that you could use for any Elixir book at the Pragmatic Bookshelf. So I want you to repeat this sentence after me. Do fun things. We can do better. Do fun things. With big, loud worker bees. One more time. Do fun things with big, loud worker bees. Okay, so that sounds nonsensical, but this is the sentence that saved the book, right? Because this this put some structure around the concepts. So what we're actually talking about with the do fun things with big, loud worker bees, these are layers. Data. We start with the right data. We build a functional core, and we test that core. We establish a boundary that has life cycles. And notice we're not saying supervision, we're not saying application, we're saying life cycles, because that's the right way to think about OTP. In workers. And so when you build your code, where do things go? Well, the do fun things, that's your core layer. That goes in this directory. And then there's the boundary layer that goes in this directory. And of course, sometimes when you're working with Elixir, the OTP stuff is already baked in, like with Phoenix. With LiveView, most of the boundary code is going to go in the live directory in a LiveView. If you're working with Scenic, it would go in a scene. But the idea is that you should have boundary code that's separate and distinct from your core code. And then you should have an API that lives there. Right? So the first part of the talk is on the core layers, the do fun things, specifically with the do. Right? The do is data. And I was always taught by one of my mentors that when you're giving a talk like this, one of the things you'd like to do is to build an emotional connection. And by the way, let's give Maggie, my wife, a hand because she picked the pictures for this, right? So basically, another connection that I'd like to make is to leave you with one word that kind of, or maybe a short phrase that talks about the connection that I want you to make when you're working with each layer. So data, the word is harmony, and that might seem like a weird word when you're talking about a functional program. But really, it changes the way that you think about this layer. Because there is a cost to immutability. If you're an object-oriented developer, then when you change an array, it's easy and it's cheap. You just drill right into the element that you want to change, and it's an order of one operation. Okay? But when you're writing a functional program, things are a little bit different because this list isn't an array. It's a linked list. And in fact, if I have a linked list with 3 elements in Elixir, how many lists is that? 3 elements. It's 4, right? So I've got the empty list and then a cons unit with the 3 and the 2 and the 1. Everybody get that? 1 list, 2 lists, 3, and then 4. So, and if I'm changing, then I want to be changing the head, because if I change the head, then I'm just writing the 1 unit, and then I'm pointing to a list that already exists, and I know it's going to keep existing because Elixir is immutable, right? Similarly, if I change the second unit, then I'm copying the 1 down, and then changing the 2 to 0, and then everything else remains the same. So things get more and more expensive as I work down the list. But it's not all bad, right? Because what we lose in inefficiency when we're writing a functional program, we make up for with better algorithms if we embrace the functional nature of the data structures that we're working with. So what I'm saying is embrace the idea of immutability. So for example, just a really trivial example, if I'm writing a bank, maybe I don't think in terms of the balance. Maybe I think in terms of the transactions that make up an account. Right? So what I'm saying is that we have this acronym called CRUD, and what does that stand for? Create, read, yeah. So I'm going to give you a better, improved acronym. CUR. Right? And the idea is that if we embrace immutability, things get easier for us. We stay in harmony. So the next layer in our code is the functions. So the do, fun, data, functions. The thing that I want you to think about in the core functional layer, this is your happy place. This is the core. This is chill, right? Because the core is about pipeland. We're not talking about withland, the complicated withland. It's pipeland. It's the place of certainty and sanitized data that's also valid data. Right? It's a library. There are no processes involved. And when we're talking about the core, hide your ears, Brooke, purity is not really the goal. It doesn't have to be functionally pure. In fact, in the example that we have in the book, we have two impure pieces of code in there. One is we have a random number, right? So what's the definition of a pure function? You have the same inputs, it's going to give you the same outputs, right? Not so with random uniform. Not so with the date time UTC now. Right? But these are pure abstractions. And pure abstractions are the goal when you're building your functional core. Now, I do have to pay some. I'll have to pay a little bit later, and we'll talk about that in a sec when we get to the test. So I've been spending a lot of time mentoring, and I think that one of the fundamental things that I try to teach is that the types of functions that we use in the core have a lot to say about the shape of our designs down the road, especially when we're dealing with OTP and live view and scenic and things like that. I didn't really put it together, but there was a man that was speaking at the last Lone Star Elixir. That was like 5 days ago now. I'm still standing. That's good. So the man's name is Melvin. It was his first Elixir talk. And he was doing a talk on the lessons on what he learned at his coding camp. He said with functional programming, everything's reduced. And I couldn't say it better. Everything is reduced. So what's reduced? I know a lot of you probably know. Probably most of you know. But let's take a look at it in a couple of different ways. Let's just break the way that, add to the paradigm of how you think about reduce. Right? So if I have this list and have this function, then I can reduce over the list and get a result. Let's look at it another way, though. And before you tell me that I'm cheating, I know I'm cheating. I'm going to catch you up later. But reduce is also this. Right? It's a beautiful way to think about reduce. So I don't know I cheated, right? Because in Elixir, the accumulator, which argument is the accumulator in enum reduce? The second, right? And when you're building a module, where do you want the accumulator? 1, right? So one of the things that I've started doing is when I have libraries that have a lot of reducers in them, rather than changing the direction everywhere that I want to use reduce, I just add a utility function called fold that has the accumulator first. It's kind of nice. So what do functions make you think of? What's the one phrase? It's the happy place, right? It's the happy place. It's pipeland. It's not withland. We'll get to the sad place a little bit later on. So. Okay, things. What does things mean? Data, functions, tests. Who said tests? Yeah, way to go. So tests. Taste of honey. Thank you, Maggie. Predictable. When you're testing in the core, this is why it's your happy place, right? Things are predictable. We don't have to worry about thinking about things that might go wrong. This is the core. So One of the bits of contrarian advice that I'm going to give you today, right now there's a big movement in the Elixir community to write your tests at the OTP level and then on forward. Right? At that point, we're doing a lot of integration tests. I'm going to tell you, test the core. Right? The more and more tests that you create that are testing your Phoenix functions, your OTP, handle calls and casts, the tighter you're binding your code to your test. So there's a great talk. So if you like watching videos from conferences, there's a great talk called Friend or Foe, Chain or Cable. It's not published yet, but you can go to YouTube/C/Groxio. That's YouTube/C/my company name, Groxio. And you can find and subscribe, and we'll tell you when the talk is published. It'll probably be the second or third talk, but it's called Friend or Foe, Chain or Cable, right? And think of a cable as one long unit where when that cable breaks, it's done, right? It's basically a big commitment, and every cable test that you add ties you down. It ties your architecture down more tightly to your software, making you less nimble. So chain tests are very important. So I say test your core. And this is also the ideal place to do things like property-based tests. So how many of you have written some property-based tests yet? Ah, that's fantastic. So this is kind of what it looks like. This is a fragment of a property test. It has the most important pieces. So there's a generator. This generator says, hey, we have a list of integers that's non-empty. And that's going to create a lot of them. And I also have properties. And this property is that the biggest item in a list is like grabbing the last element of a sorted list. Right? And so I basically go through every element from the generator and build a property-based test on this. So here's a bad dad joke. This is the article I took the example from. Also props to John Hughes, creator of QuickCheck, and to Fred, who wrote Erlang and Anger, but also the most excellent property-based testing with proper book. So I also want to give a hat tip to the idea of pipes and tests. If you can build, remember the functional core is your happy place. So we're talking about predictable flows. And if you can build flows with pipes, they tend to tell a little bit more of a story. So this is an example from a Tetris group that a Tetris video that I teach, where we're trying to look at the individual mechanical pieces that we need to do as we manipulate the Tetris blocks. But what I want you to look at is that every even step, the points.mirror, the points.flip, the points.rotate, all of these things tell this natural, nice story. And every odd block, except for the first one, those are assertions made possible because they basically use reducers with side effects, right? Assert isn't actually a pure function. It's a pure function with a side effect. It raises and collects data based on the broken test. And that makes it very easy to write this assert point function. This is the custom little function that I wrote. So basically, this is the input, and I'm going to return the same input, which makes this also a reducer. And then I take the expected value and assert that the expected and the actual are the same. So it's a cool little technique to add some sanity to your tests. So earlier I said that we were going to have to pay later if we introduce some impure concepts to our core layer, well, now we get to pay. So, but we're only going to pay a little because there's this great technique called stream, or a great function called stream repeatedly that works very well with XUnit. So in this case, in this function, we're building this quiz, and it has this function in there called build question, which has some random substitutions. You can imagine if you're building a first grade quiz for little Johnny or little Susie, and you're trying to say, okay, 1 plus 4, and then 3 plus 7, and then have the little munchkin come up with the answers. And you have to test this, but it has some random data in it. So one of the things that I can do is say, repeatedly try this, and then with this stream, do a find until you hit the number that you're looking for. And if everything works, it should be very cheap because I should only have to call that function a couple of times. If you fail, what's going to happen is we're effectively going to time out and fail the test. So, basically tests and the do fun things is predictable. So now we're going to move on to the boundary layers. We're going to be working with the big, loud worker bees. Anybody follow the Twitter feed or the early talks on this book before? What was the worker bees before? Anybody remember? Who said? Wildebeest, right. So, and that was great because James had just come off of a trip to Africa. And we were picturing a book with a wildebeest on the cover, and then, by the time that it was time to build the cover, we couldn't do it. Who can guess why? O'Reilly, right. They have the animals on the cover. There's already a wildebeest book. There's probably already several wildebeest books. So we said, I bet we could get away with like a mechanical-looking bee, right? And then we thought about it, and there's all the cells that work together, that kind of like the component sort of architecture that we're looking for. There's the workers, which is actually one of the pieces of it. So James lobbied that I change all my artwork and the whole book from a wildebeest to bees, and I said, okay, but you have to make the changes, and he did. So the first one is big, loud worker bees. We're going boundaries, life cycles, and workers. I'm going to start with the boundaries. Brace yourself because I'm going to show you the dirtiest word in a programmer's language. Maybe. Maybe. Does it work? Maybe. Sometimes. I hate that, right? But that's what we're dealing with when we're dealing with the boundary. Because the boundaries are the sad place, and not just for OTP, right? This is where you inject the complexity and the uncertainty and the processes and unclean input. And we're moving from pipeland to withland, right? The sad place. So maybe you want more pipes and more reducers and more happiness in general. So what should you do? You should move your data, move your code from your boundary to your core. So one of the concepts in the book is we are religious about having very skinny handlers. Very serious about this. So another one of the techniques that we use, we're always looking for ways to move us from pipeland to from withland to pipeland, from my boundary to my core. And one of the ways that I can do that is to represent data as errors, right? Or represent errors as data. You would think I would have caught that the first time I gave this talk. Represent error as data. Let's fix that problem real time here. Oh, I can't do that. Now I'm in trouble. There we go. Okay. Okay. So the way that it works is that I have this code, right? Breaks some of the time. And all I do is I wrap that in a try and return the error. So now, instead of working with an execution flow, I have a stream of something, or I have a list of data or a stream of data that I can work with predictably, and maybe I can shift some of my code from with land to pipeland and work with it more predictably. So the second example, this example composes in a way that you can't with just a straight exception flow. Okay. So the dirty word for all programmers is maybe. Okay, the next one is loud. And I'm not quite sure how this little piece is going to go over here. We'll see. So the word that I want you to think about is paradigm. So most people, when they're teaching OTP, will teach about supervision. We believe that the right paradigm for thinking about OTP is lifecycle. If you think about it, what's the vocabulary? Start, stop, right? These are life cycle times of things. So who has seen the movie, or who's seen the British comedy series, The IT Crowd? Yes! So when people call down to the basement, what did they say? Did you try turning it off and on again, right? Because that's the secret to reliability. It really, really works. Right? And that's that's the genius of Joe Armstrong and Robert Verding and the rest of the Erlang team. So all the types of features are related to the life cycle. Even things like this, right? This is an example from the book. You have to find something. You have to have discovery right to get the life cycle right. When you start thinking in terms of life cycle first, then discovery so that you can work with life cycles, and only then start to think about supervision, it's a lot easier to internalize what's happening with OTP. So the idea is that if you get startup right, and not just startup for you, but startup for your children, and you get teardown right, then you get reliability almost for free. And that's the OTP goodness, right? So I haven't really told you anything new. I've just hopefully planted a seed to start thinking in terms of paradigm. Instead of thinking supervision, think life cycles. That's right. Everybody's still with me. Pretty late in the afternoon, and I'll take that as a win, right? So the last layer. Okay. If I didn't get in trouble with the last section, I'm probably safe here, but I'm not quite sure yet. We'll see. So workers, and the word that I want you to leave you here with is balance. So right now, I believe that there is an imbalance. I believe that if you look at a typical Elixir developer's code, you'll see more widths than pipes. I don't think that that's a healthy thing. I think that that is a code smell, basically because we have more work in the boundary than we should. So one of the first lessons that you learn in the Haskell language is to try to move as much work as you can from the boundary, which is done with a more sophisticated type models and concepts, and invest more in the core. So I'm not arguing for perfect balance. In fact, maybe I'm arguing for imbalance towards the core. So here's the controversial thing I'm going to say that's going to get me in trouble. Come on, bring on the hate mail. I can take it. I'm looking at the camera here. I want to delay the code that does persistence. So one of the things that we do, because of the tool sets that we're working with, because of some of the examples that are out there, is we bind ourselves directly to persistence way too soon. And the minute that you talk about the database interfaces, you're talking about withland. You're talking about the sad place. Right? So one of the tools, one of the tricks that we do in designing Elixir systems with OTP is we say, hey, persistence doesn't need to be built into the center of the core. In fact, it shouldn't be. What it should be is a callback function that we can apply. Here's what it looks like. So I have an alternate. I have a configurable persistence function that I can drop in, and then in the boundary, I call that persistence function with the value that I'm creating. Right? And so in this way, so the meat of my code doesn't have to worry about the persistence mechanisms at all. I think that's really important, and we've used this technique pretty successfully as to reduce the amount of code in the boundary and shift more code into the core. Right? So the word here is balance. Less in the boundary, a little more in the core. So that's do fun things with big, loud worker bees. So I want to take a little bit of time. James isn't here, but I want to give him a hand. He's a great man. Great book. Love you, James. And I'm going to wrap up early, so I know I'm going to get a lot of questions. So, yeah. Questions?
So you talked a lot about like comparing the withland with pipeline,
yes.
But sometimes your core, like your domain, is kind of like a with. Maybe your domain has to do some decision, like I don't know, have to check if the balance is bigger than 0, then okay, or I don't know, something like that.
Okay, so I'm talking about withland with error tuples, right? So if you're using with to do some other type of pattern matching, that's not the withland that I'm talking about.
Okay.
So we're seeing more and more of an explosion in Elixir. Don't get me wrong, with is a great thing, right? It allows me to reduce these wildly nested if-then-elses that we saw in the first few years of Elixir. It's a wonderful construct. But I think that if you're seeing withland with error tuples way in your core code and you're not seeing any pipes, just consider that maybe you've got some boundary conditions that are creeping in too soon. But great question.
Okay.
So you touched on this a little bit, but something that I see very often in Phoenix projects, both my own and other people's, is people using the ecto schema structs as kind of their domain model. I get the impression that you recommend against that, but do you have any advice on translating between that layer and the core structs that we should be building?
So it's actually designed very, very cleanly, and Eric, by the way, marvelous job with ecto. This isn't an ecto rant. Basically, it's designed, you'll notice that the repo separates the things that require persistence from the concepts in the schema. This was done intentionally so that we could expand the core and reduce the boundary, right? But what you're saying is that very often in the module that has the schema, we'll see a lot of repo code. Mm-hmm. And to me, that's a code smell, right? I would much rather see the repo In Phoenix, it would be in the context. In our mastery code, it would actually be in a persistent service that we attach later.
Okay.
So that's kind of what I'm talking about.
I don't want to take up too much time, but it's kind of a
Sure.
follow-up then.
Yeah.
What about cases where the core domain model doesn't map one-to-one with maybe the ideal schema in the database?
Yeah, so that's a great question. And so one of the things that I have taken to doing, and actually I've got a startup called Groxio, and we're building a lot of educational tools. And one of those things is like some lessons, right? In the lessons, we've changed philosophies and structures with the lessons many, many times, right? Now, every single one of the changes, except the last one, I did before I even attached persistence to anything at all, right? So basically, one of the things that I love to do is build a lightweight OTP model, or even just a skinny functional wrapper, and basically live without for a while. And only when I've kind of settled on the structure, I'm dealing with the struct rather than ecto fields, but with the idea in mind that I could later drop in ecto fields at the drop of a hat, right? Mm-hmm. So only once things have kind of simmered down a little bit do I cut my first migration, right? Because migrations, especially data migrations, as you're trying to iterate rapidly, are poison to productivity.
Cool, thank you,
So
that's really
great
helpful.
Question.
What about life cycle in the sense of the whole program and bringing up services in layers as opposed to supervision?
Okay, so the question is, what about life cycle in terms of the whole program? And basically, essentially, this gets into a lot of other issues like dynamic supervisors and things like that. But if you think about life cycles from the perspective of you and your direct descendants and your direct ancestors, that's your parent and your direct children, then you're done, right? Then the policy, so then you can focus on getting that part right. When you have it right, you have everything right, everything else right that you need to. Then everything is about the configuration of policy. So, yeah. You see what I'm talking about? So, but this is exactly the idea. So if I'm trying to think about supervision for everything, then I'm dead. But if I think about life cycles, then I can think about how do I start this cleanly? How do I tear it down cleanly? And the policies come easy. The configuration comes easily.
Any more questions?
3 more minutes. You got me?
No? Okay.
Thank you.